Okay. All right. So we're given three factors, and I tell you what they are, and you need to determine what is the dependent, what is the independent, because there's usually only one y in these types of problems. So we're doing multilinear, meaning there's two factors. Two of these will impact one of the others. So you have to first identify what is x and what is y, or what is dependent, what is independent. So sometimes it's not clear. You kind of need to think about it. So when you get older, blood pressure should be affected by age. So this is going to be the one of the independents. This guy over here is the weight. Weight also affects pressure, so that will also be independent. So the dependent is the y, and that's the one you need to identify first before you do anything. Is the dependent variable. So these two factors, x2 and x3, are going to impact x1. So we're going to do a multilinear regression, meaning you have more than one factor affecting an outcome. Okay. Then we're going to write down what is the p-value for the model, and then we look at the p-value for each factor, meaning are these both significant? In other words, do they actually affect blood pressure? Which factors are significant or not significant? So if they don't, you'll say which ones don't, and then you'll write the equation. But since we have multiple factors, the equation is not going to be ax plus b anymore. It's going to be y equals ax1 plus bx2 plus some constant, which we'll call c for this particular example. And I don't mean the specific x1 and x2, I mean just in general, right? So for this one, we would have x1, actually the age would be one of the factors. So x2 and x3 would go here. So once you do the actual question, you'll write down the real equation, but this is the general form. So let's figure out what it is, right? So if you have added well, I haven't added it, so I'll show you how you add the add-on. Since I just installed it, go to options, go to add-ins, and I'm going to choose, where's data analysis? Analysis toolpack, yeah, that should do it. I'm going to hit go. I'm going to go ahead and add this toolpack, the solver, and I don't know, Euro sounds cool, I guess, whatever. So they should appear here. So there's data analysis. So I hit data. Now that it's inside here, now that we have it in Excel, let's go down to regression and hit OK. So in here, we start selecting what is what, right? I always pick labels just because I like to highlight the whole thing. And when you do plots, it's going to have the names attached. Confidence interval will be 95%. So meaning the error of this analysis is only with, we only have basically a tolerance of 95%. So if it's somehow outside of there, then we won't accept it. And we're not going to get into detail what that means, because that's like a lot of statistics. But just think of it this way: we're taking everything within that. We're 95% confident that this output is legit. Okay. So output range, I'm going to choose it to spit it out down here somewhere. Y value is going to be, we said, blood pressure, the dependent variable. X values is going to be both these two. I'm going to do the plots. Don't really need these, but if we're going to do deeper analysis, you choose those. And then hit OK, and it should spit everything out. So now we have p-values for every factor. And this is the one that we care about that tells us if the model is good. So this one right here, regression significance, that's one we want. So that guy tells us the p-value of the model. So I'd say, you know what, that's very tiny, 2.87 times 10 to the negative 7, right? Now we can just do it here, see what it looks like. 2.87, let's put equals first, equals 2.87 times 10 to the negative 7. So that's our actual p-value. So there it is. Pretty small. The smaller the better. Since I'm using a 95% confidence interval, then you want this p-value to be less than 0.05, because that's the 5% that we're not accounting for. So clearly this is way below 0.05. So the smaller, the better. If it's really tiny, then right away you say, yeah, that's a good model. And then we look at the p-value for each factor, right? So that's going to be these. Here are the factors. Okay, so these two are the ones I care about. So, okay, so I'd say the p-value for x2, which is, I already forgot, age, right? Age is 0.00844. And p-value for, let's see here, x3, which is weight, is 0.033508. Okay, so then you figure out, okay, which factors are significant or not significant? Well, if the p-values are too large, you'd say, you know what, it seems like weight or whatever is not significant. So for example, this is 0.03. That is below 0.05. So this is technically still okay. So you can say with 95% confidence that both factors, oops, not typing, both factors are significant. I can say both age and weight are significant and have some impact on blood pressure. Even though I know nothing about blood pressure or any of that stuff, given data, we can still do analysis to make, to determine different things. Make a little space here, it looks a little prettier. So these are the p-values. Okay, and yeah, so they impact blood pressure, okay. So what is the equation of the model? So now this guy, you just fill in the blanks, right? The A and the B and the C. Those are these right here, these values. So the value on the X3 is actually that bottom one, 0.33. So you'd say 0.334859. And the A is actually 0.861, 861, right? Yeah, 415. And the constant is the C at the very end. That is 30.9941. So this is the model, the equation of the model. And the questions that we did earlier, or last time on Monday, they were just mx plus b. It was just, there was just one factor, right? And that was it, and the intercept. But in this section, we have multilinear regression. So let's go ahead and do some of these examples, since I think we only did one of those last time. Do you guys have any questions on that problem? Does that make sense?
Yes, it makes sense.
Okay, so that's what you're looking for. This tells you about the model. These are the coefficients that go in the equation. These tell you if it's significant or not, these factors. So we're trying to measure what is impacting blood pressure, right? Like if people do studies on drug tests or sorry, drug studies, like on I don't know, let's say you're testing 4 or 5 different treatments on, let's say, cancer or something, right? You look at all the data and you try to determine, okay, which factor actually had an impact. And then you start to, the first level of analysis would be something like this, right? You start to kind of isolate which drug did something. And then you do deeper research and deeper analysis into that particular factor. It's kind of what this is for. You kind of start a brief, not too deep of an analysis, just kind of it's an intro to just to see what's happening, to guide you what to do next. Okay, let's do the next one together. All right, so you guys have this file? I think I sent this to you, right?
Yes.
Okay. So let's look at this guy here. We have 3 exams and a final. So test scores for general psychology. X1 is exam 1, X2 is exam 2, etc. So we're going to have a multilinear regression because we have 3 factors, and the question becomes, what the scores that I make on exams 1, 2, and 3, does that give me a preview, or does that show what could happen on the final? So if you think about it, let's say you ace every single exam in some class. I think it's safe to say that you may also ace the final, right? If you continue as you've been doing it. So we can use these as factors to see the test, right? Do these scores actually impact the final grade? So if we have the final grades here, do they impact it, right? And it seems like it'd be a yes, but let's find out. I don't know. All right, so go to data analysis. Okay, regression. All right, I'm gonna hit labels. Everything's the same. This guy I'll choose here, I guess. The Y variable. All right, so this is when you have to use your, I guess, common sense, right? Trying to think about it. What impacts what? Well, I think these will impact the final exam. So we'll choose final as the Y value. Oops, crap, go back. I will choose the 3 exams for the X range, X values. So these are the factors, and this is the outcome. So do these factors impact the outcome? That's what we're looking for. That's what we're trying to check. All right, so here's the model. So here is the value I care about. This tells me if the model is good. It's pretty small, so I want to say yes. We have 3 factors and an intercept right here, and the p-values for each one. It looks like all the exams have some impact. They're pretty small. Exam 1 has a smaller impact, which I guess kind of makes sense. I mean, it's still technically impacting it because it's less than 0.05. But people tend to do worse on exam 1 because they don't know how the teacher tests or grades, and then they figure it out, right? So it makes sense that exam 2 and 3 has a bigger impact because at that point people know what they're doing, hopefully, or they've already shown they're not going to pass, or they are going to pass. So it seems like that's a safe assumption. Okay, and then these values, remember we talked about last time, tell you, is there a linear trend? So this one right here. The R-squared value tells you, if they ask, how linear is this model? Okay. The closer to 1 or -1, the better. This is very close to 1, so it's pretty good. It's very linear. The p-value of the model, well, that would be this guy. Okay. P-value for each factor, that would be 0.007961. One p-value. Then 2 p-value is super small. Then 3 p-value is okay. So those are the p-values for each factor, where exam 1, 2, and 3 are factors impacting the final exam score. Which factors are significant? Well, they all are. Exam 1, exam 2, and exam 3 are all significant. What is the p-value for each factor? Oh, I already did that. I don't know why I wrote that twice. Okay, let's try to make that prettier. This gets messed up. Enter. Enter. Okay, so equation model is basically going to be just ax1 plus bx2. So it's just a coefficient on every single factor. And then you have your constant. So A, B, C, D. Okay, so then you just fill them in with these values, right? So the coefficient of the x1, well, if x1 is the exam one, it's down here, that's going to be the coefficient. Okay. So then you put that here for the B, replace the, sorry, for the A, replace the B. That will be here. Replace the C. That will be remove that space there. C is exam 3, the coefficient, and then the constant is the last one. It's also called the intercept. There we go. I'm going to put extra note here, and impact the score on the student's final exam. Okay. So whenever you do any kind of like research or study or some experiment in science, at a certain point, when you collect the data, you do have to refer to statistics and p-values. So whenever someone publishes like some sort of research or a discovery, usually their p-value has to be pretty good. And like, for example, when they were testing out different medications for COVID or whatever, they would look at the data and determine, okay, is the p-value low enough? And if they notice it's too big, then they throw out that medication. You know, like, clearly hydrochloroquine or whatever is bullshit, so they move on, etc. That's usually how it works. They just keep testing. The more data, the better. The more data, the more you can trust your outcomes and your findings. If you have any questions on the exam problem? All right. All right then. I'll go ahead and share this with you. Now we have more examples to look at for later. Okay, so in your homework, I don't think I don't think I gave you any multilinear if you look at it. I think they're all basic linear. We're already out of time, but let's check this out. Your homework problems, they're just one variable, one factor, one outcome, right? One factor, one outcome. And that's it. I don't think I gave you anything too difficult. I mean, it's a lot of stuff, but not as difficult as the ones we just did. These are more like what we did on Monday. So they will ask you for what is the p-value for the model, right? And then you'll determine is it good. You'll write in the R-squared value, and that will tell you if it's how good of a linear relationship you have. And remember, linear relationship is determined by how close that value is to 1 or -1. If it's really close to 1, then you have a positive linear relationship. If it's close to -1, you have a negative linear relationship. And as long as it's close to either or, you have a good relationship. But if it's close to 0, then there is no relationship. So you'd say, the model can be trusted. Okay. And then when you find your equation, right, you can plug in numbers to test out the future, right? So you can plug in 2004 into the equation that you find here, and then you'll have an estimate of what will happen. Will be the Olympic vault in 2004. All right, guys, we're out of time. Do you guys have any questions before we head out?
No, sir. Have a good weekend.
All right. Let me know if you guys get stuck or anything. I'll see you guys Monday, otherwise.
Thank you. See you on Monday.
See you Monday.